Bismillah ar-Rahman ar-Rahim. June 24, students, we have a paper, variant 51, and complete statistics paper we are going to start. So get ready. Question number 1, students, we have a summary of 20 values of x given. So sigma x minus 30 is this, and this is a square, and 25 values given here. So here 20 values sum, here 25 values. And he said mean of the all 45 values. So if you remember the formula, we have this coding method student we're using. So how we can find it, students? So first of all, the sum of this one. So we have a mean formula. This is the values of sum of the values of 20 values, okay? And is a mean of the 25 values. And how to get a mean? So simple, 439 plus 470 and divided by 45 values. So this is clear. Okay. And and if we have to find, look at here, this is 30. Can you see 30? Basically, what is the formula of the mean formula? We have coding method is x minus 30 over n plus 30. So this is a formula basically we have. So when we have this formula, we have, okay, for mean, what we do, students, so this 30 we add always, okay? So it means if you are looking for this one, so what is the method? We add 30 here, and this value comes from this 34, 39. So same way, if we have to add two values, so 30, 30 common, and that is why this 30 comes from there. Okay, I repeat again, and that is a way to find the average, because if I just show example to understand, 20 values mean is 439 over 20 and plus 30. This is very clear. Okay, and similar approach, if I go for the other 125 mean value is this one, I can tell you. So 470 over 25 and plus 30. So if I this is a reason, if you want to find out the mean of the all values, student, what is the technique? Okay, so so that is why we just add this 30 here, and if you check it, there's a logic behind it. And if I find it, the answer will turn to be what? So 50.2 is the average of the all 45 values. So let's talk about the next one, deviation. And what is the deviation technique? Deviation technique is formula. Let me write deviation formula. And deviation formula we have is what? Sigma x minus 30 whole square. Okay, and okay, and then we can say here, this is a value for that one, we can see clearly, and then addition of x value. This is a 25 values, and these are 20 values. So I'm going to add them. So it means, and by n, and minus mean of the whole group. Okay, so minus mean, and mean is we have a, if we just calculate, just a minute, let me calculate myself. Okay, all right. Okay, so this value, students, sigma is this value you can see from here, this and this addition. So 12405 plus second value is 11346 and divided by 45 and minus, and do you remember, student, in this kind of question we never use 30. Okay, so if we check it, 439 plus 470 and divided by 45. So this is coming with us 909. Let me check in calculator. 439 plus 470. Okay, so this is without this number, we'll plug in this number here. So it means this is square comes, and here 45, and upper number is, if you add 439 plus 470, become 909. I hope so you understood very well, students. And now if I subtract them, and this is giving us the mean deviation, and now I'm going to type this value as well in calculator. And this value is coming with us is 10.9. Once again, I repeat once again, because some students confuse. We sometimes students put the whole thing inside here. Not at all. Without 30, we put this value inside. This is the main part important here. So that's it. And question number 1 is completely over. Question number 2, student, we have lengths of a tails of a adult raccoons of a certain species are normally distributed. Okay, and mean is 28 given. Okay, mean is 28. And deviation is given 3.3. And find the probability random chosen, the tail length between 23 and 35. So length between 35 and more than 23. So how do, how do this kind of question? We have a special formula, when we have a x minus mean by deviation to convert and into standard form. And this 23 will go in the place of x. So 23 minus mean over deviation. And I write z same time. So 35 minus mean over deviation. Okay, students. So now I'm going to type in calculator and get the values. So this value I'm getting is here is negative 1.515, and other one I'm getting 2.121. Okay, and student, we have a formula. One value is in positive, this is a positive, and this is a negative. And if we need a middle area, whenever one positive and one negative, so what is the formula for it? So look, I'm writing here, if this A positive and B is negative, so phi of A plus phi of B and -1. So same story I'm applying here, phi of 2.121 plus phi of 1.515 and -1. So this is a whole thing, and I'm going to apply. And let's see now in the table we have, okay, let me try. So first value I'm looking for is phi of 2.121. So 2.121, so 2.121. So this is a line we have to use. Okay, and 2.1 from there. And then I talk about 2, and 2 is this. And the 1 is coming from here. So basically, we are having the answer 0.9830. 0.9830. 0.9830. And what about this one, students? So 515, 1.515. 1.515. So 1.5 is here, this line. So 1.51. 1 is this number. And 1.51 and 5. 6. So we have to check it. So 0.9345. And if we add 6, so 0.9351. 0.9351. 0.9351 and -1. So just typing in calculator and answer is coming with me 3SF9 0.918. I hope so. The point is very clear. And let's go for the part number next. Masses of adult raccoons of this species are normally distributed with a mean 8.5 and deviation unknown. 75% adult of this species have a mass more than 7.6. So I'm writing here mass more than 7.6 kilogram is 75%. Again, I'm using here Z. So 7.6 minus mean, and that is a 8.5. Deviation is unknown. And 75% means, students, 0.75. Okay. Now, so this is coming 7.6 minus 8.5, and we are getting here and negative 0.9 over sigma. As this value, student, is negative, so have a look, please. Right side positive and left side negative. So I'll take left side negative here, and negative 0.9 over sigma is more. More is called this one. But we don't have this kind of in the table, so we can go for the same diagram. If I make it with a positive side, so it becomes 0.9 over sigma in this area. And this probability is same always. So it means this is representing from left corner, if I go this way, is called phi of 0.9 over sigma. So I'm writing here phi of 0.9 over sigma and is equals to 0.75. Okay, this is a clear. And and now we can do what, students? So this value is very clear, 0.9 over sigma, and this is 0.75. We go back on table and see from there, but this is a special value we have available below the table. You can see probability 0.5 and 0.674, 0.674. So I'm writing here 0.674, okay? And now this is basically 0.674 and phi of that, phi of this. Phi cancel, and 0.9 over sigma is equals to 0.674. Okay, so if you type this in calculator, so simply we get a 1.335 or 34, and this is my final answer. I hope so. The concept of the question is very clear. So question number 3, students, we have, okay, and what is the question? So histogram we draw, okay, frequency given. And students, whenever frequency given, how to make a histogram? And first of all, check it. Are these numbers are same or not? Are they same or not? Step number 1. If they're same, then alhamdulillah. Otherwise, what to do? If they're different, then subtract and divide by 2. For example, is 151. So 151 minus 150 and divide by 2. I got 0.5, and 0.5 add in upper limit and subtract in lower limit. Add in upper limit, subtract lower limit, because that is called discontinuous data and convert into continuous. But here, not a problem such we have. So let's try do it. So how we can do this one, students? Get ready. Check it. Formula is frequency density equal to frequency over class width. So what is the frequency density? Frequencies are here 16. And a gap is what? The 20 gap. 20 gap. If I divide them, so 16 over 20, so we are getting here 0.8. We are getting here 0.8. This part is very clear. Okay. Now, same way, we'll find out the other also. 0.8 is coming here. What about this second column? 32 divided by the gap, 10. So 3.2. And now 76 divided by the gap, and gap is again 10, so 7.6. And 64 over 5, 64 over 5, yes. So that is coming with us is 12.8. and last column, 12 over 20, 20. And I'm getting here 0.6. I think all values are clear. Now I'm going to draw. Okay. So, sorry, thought problem and lot of disturbance. So this is clear. Okay, students. Now, what is the values along x-axis? Very simple, starting from 130 until 150. Okay. So I'm starting here 130 or so I said before. So I will start from and start from here and show a compression, and this is 130. And what is the highest value is a 200 approximately. And if I check it, if I subtract, so I need a 200 minus 130, 70 gap. So 40, 50, 60, 70. Wait a minute, let me check. 30, 40, 50, 60, 70, 80, 90. Correct. All are coming in range. And let me check 90. Yeah, 95. So it is correct. Okay. So I'm writing here 140, 150, 160, 170, 180, 190, and 95 also there. Now, highest frequency we have what? 12.8. 12.8, it means almost 13, we can say. Check it, it's 13 boxes. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It means one box is 1. So we have the values available, so no problem at all. Okay, now let's start. First one starting 130, ending 150, height 0.8. And before I start, because I've taken 1 here, what is the formula? Value by number of boxes. So value divided by number of boxes. So value is 1 and boxes are 1, 2, 3, 4, 5 boxes. So 1 over 5 is 0.2. So it means one long y-axis is 0.2. So let's start. So it means I'm looking for what? 0.8. You can see students on top, 0.8. Starting from 30, 50 and the height is 0.8. 0.8, it means 4 boxes. So 4 boxes. Shading is not compulsory. If we do it, good, okay. Done. Second column, students starting from 150, ending 160, height 3.2. Height 3.2. 3.2 is one box above 3. So 3.2. I hope so. This part is also clear. Third column. Third column is, students, what we have is a 7.6 and 10, okay. So 7.6. So 7.6, 3, 4, 5, 6, 7, 7 is here. 4, 5, 6, 7, 7.6 is 3 boxes. So I hope so. Nothing hard at all. Alhamdulillah Rabbil Alameen. Easy. Let's go for next column. Next is 12.8. 12.8 and and 5 box. It means one box 12.8. So 8, 9, 10, 11, 12. This is a 12. And this is 13. And 12.8 is one box below. This 12.8. And this time I will take this only. Okay. I hope so clear. This is also done. So this part is done as well. Because he said that 70, let me check again. 70, 75. Correct. Okay. Now students 75 to 195 and 0.6. 0.6. 0.6 is 3 boxes. So I believe that this is nothing hard. Alhamdulillah Rabbil Alameen. We have done it. And now let's talk about the next page, next part. Part B, the interquartile range is R and show that R is not greater than 15. And what is interquartile, student? We have to find out upper quartile and find out the lower quartile and then subtract them. Upper quartile, student, 3/4 of N, okay? And here total frequency we can say, and that is, I think, 200. And low quartile is 1/4 of total frequency. So 1/4 of 200. So if we check it, this is value is 3/4 of 200 is 150. And this is 50. So let's try to find out which groups because we have a given groups where, first of all, lower quartile 50. So let's go where 50 locates, check it. So 50. So we'll find out the low quartile, which section we have. So 16 plus 32. If you add, I get a 48. So it means 48 is this one. It means I'm looking for 50. So it means first two columns frequency, if I add, I'm not reaching 50. I have to add this 3. It means lower quartile lies in this interval. So lower quartile is having this interval. Very clear. Because if I add them, I'm not getting 50. So I have to add a third one. So it means this is a lower quartile range. And let's talk about the second one. Second one, student, upper quartile range is coming here 150. 150, we'll check it where 150 will come. So 150 is here. If we add, let me check in calculator, 16, 32, 74, and I check the other one. So I think so 16 plus 32 and plus 76. I'm getting till here 124. If I add 64 students plus 64, I'm getting 188. So 188. It means this is my upper quartile range. So upper quartile range is here. So I think it's very clear now. I'm writing now. So 160 till 170 is a lower, and 170 till 175 is upper. I think this part is clear. So I'm going to take it now on the other page. So I'm writing now here. This is clear. So I'm going the range. The range for upper quartile is this. The range for upper quartile is this. And range for the low quartile is this. Now he's asking the interquartile range is not greater than 50. So highest value, if I check it, the difference between the highest, okay? So highest difference is coming from here because this is a 0, okay? Even this is a 5 only, and this difference is 10 only, but the highest difference is coming here. So highest range, so range, if I get it, is 175 minus 160, and I'm getting here 15. So proved. And he was asking, show that it not greater than 15. I hope so. The concept of the question is very clear. Question number 4, students. A game of the 2 players is played using a fair four-sided dice with 1, 2, 3, 4. One turn consists of throwing the dice repeatedly up to the maximum of 3 attempts. It means we can try 1 attempt, second or third. When 4 is obtained, no further throws are made during the turn. It means turn contains maximum 3 terms. Look, let me make it a bold. So maximum 3 terms. Okay, but if you get a 4 in the beginning, start. So we'll stop same time. Player who obtain 4 in their turn will score 1 point. All right, show the probability the pairs obtain 4 in 1 turn. So you know what is possibility, students? So maybe he get a 4 in first attempt. Let me write again. 4 in the first attempt, or maybe first attempt he's not getting 4, and second attempt he's getting 4, or maybe first 2 attempts he's not getting 4, and then he's getting 4, because he said that as he obtain a 4, and he will stop same time. So for example, if he get a 4 in first attempt, so he will stop same time. Or maybe first time he's not getting 4 and he will try again. I got a 4, stop same time. Or last option, not 4, not 4, and 4. So let's try to do it. What is the probability of 4? Probability of 4 is naturally we count as a P, and there's a 1 over 4. And Q is naturally 3 over 4. Why? Because we are not considering then it is 3 or 4. So let's start. 4 means 1 or 4. So I'm getting here 1 or 4 plus. And not 4 means 3 or 4. And now 1 or 4, it means 1 by 4. So I hope so this part is clear. And last attempt and finally, 2 times not 4, not 4. So 3 over 4 into 3 over 4 and then 4. And it is 1 over 4. So I think clear. Now I'm going to type in calculator, students. And let me check what I get. 3 divided 4 into 3 of 4 into 1 of 4. It's coming with us. Yeah, he said prove it. And we have proved, okay, we have got a same answer. So 37 over 64 is our answer and proved. And now next part is what, students? X and Y play this game. Find the probability neither X or Y score any point on their first 2 turns. So this is the answer when he scored on first turn. If I say that, for example, let's talk about X. So not score, like no score for a first turn. First turn, no score. First turn, no score. So naturally, it means score is this one. If I say no score, I must say 1 minus 37 over 64. Repeat my words. Scoring means scoring in any one attempt is this much. If it's a no score, so 1 minus that. I think idea is clear. Now, a second term. Okay, I think we have to talk about again sex. Again, this one, I think I have to copy once again. Hold and copy again. Copy and paste. Okay, now I'm going to talk about this is X second turn, turn or term. I think turn. I say that second turn, no score. So there's an X. Okay, X person. Now same way we can go for the Y person, and how we can do it now, students. I think very clear. Copy and I'm pasting, saving my time. Okay, this is a story. Now we talk about Y and Y. So Y first turns, Y second turn. So I think this idea is clear, and we have to multiply Y because this is just like a branch. And we write this way, or we can write all together 1 minus 37 over 64 to power 4. And answer is what is I'm getting here, students. So answer is 1 minute. Let me check in calculator. So answer is coming with me is 0.0317 after rounding 3 SF. I hope so. The concept of the question is completely clear. Student C part, we have X and Y each. They have the 3 turns. Okay, it means 3 turns by X and 3 turns by Y. Previous part we've done 2 turns, and now find the probability X and score 2 more points than Y. Okay, and every turn when you get score 4 is counted as a 1 score. Okay, now he's saying X score is 2 and as 2 more. Sorry, the difference of X and Y is 2. It's very clear. X scored 2 more than Y. So we have how many conditions? We have a conditions, we can check it. Now have a look here. We have one condition. If we have X score 3, X scores 3 students, and Y score 1. And that is why the difference is coming 2. And that is said X more. Second option, if I can say that if X score is 2 and Y score is 0, then also we got a 2. And let me check third possibility. 3 is 2 0. 2 0 and 3 1. The difference is 2. And any further? Both zeros, 0 0, 1 2. Okay, I think that's 2 possibilities we have. Okay, student, let's try to do it now. So how to do this kind of idea? Let's talk about X person. So X score is 2 and Y like is 0. That is what difference is coming to. So let's see how we can do this kind of concept. if I talk, and you know very well, we will go back and see the scoring and not scoring. So this is a if you obtain this target is 37, and if you check it, this one not is a out of 64 subtract 37, and we are getting 14.7, and there's a 5, so 27. So 37 over to 64. Let me check both numbers. And second number at 27 over 64. So this is a for score, and this is for not score. So I just take this values and bring on the another page. Okay, so let's see now, students. We have the plan now. Inshallah, I'll try to fulfill now plan. Let's start. Okay, the situation what we have, student, number one situation. So x score 2 time and y score 0, and that is why it can be fulfilled. Okay, how we can do it, students? So x is 2 times. So it means I can say here score by x, and again I can say, wait a minute, let me check, scored by x. And because we have three turns, make sure total turns are 6, because how 6? 3 turns by one person and 3 turns by second person. So we have so many branches, we have to check it. But look at now. So when I talk about score 2 times, so how we can write it? So we can write scoring is 37 over 64. 37 over 64. And I'm writing here power 2. Why power 2? Because we have to get it now. Okay. And what the other person, when you talk about, okay, 1 time, because 3 terms for x person, okay, 3 terms for x, okay, x1. So I got not scored by x. So it means not scored by x. So 27 over 64. So student, this is basically x only. Now I talk about y. So y is not at all, no scoring. It means I will take not scoring and power 3. Why power 3? Because all 3 attempts he is not able to score. I think point is very clear. Let me explain again. Once again. So this is a more important part. Why I taken power 3 and why I taken power 2 here. I just give you an example to understand. This is attempt 3 attempt of x, and this for x only diagram I made for you. Okay, so 1 time he score and not score. That is why scoring and scoring power 2 and not scoring is this one. That is why I taken not score 27 and scoring is 37 to power 2. I think this part is clear. And when you talk about the other person, why not scoring, students, so not score, not score, not score. So that is why I have taken this and power 3. This is done. This is not a hard. I hope so. You understood very well. Now this part is clear, but one part is important. Okay, that discuss later. Now I talk about second condition. Sorry, I talk about this condition. So 2 0. Sorry, this is done. I talk about 3 1. 3 1. X is 3 and y is 1. X is equals to 3 and y is equals to 1. Okay, student, what is how we can do this kind of option? Now all 3 options, x is scoring. So scoring is there for x. So I will write a say this is the scoring. So I will take 37 over 64, but power 3. Why power 3? All time he is scoring. Okay. And now the other person is scoring 1 time, but 2 time is not scoring. So this is a for y. So this is a scoring, so 37 over 64. And now this scoring. And not scoring is, this is scoring. And what is about not scoring? This is called not scoring. 2 times not scoring. And it is coming with us 27 over 64 and power 2. So I think, student, this is also clear to you. But now last thing left behind. I will add this to both answers, but one part left only. And what is that last part left? Important part. Important part left is with us is this will multiply with let me decide how we can explain to you. Hold on. 3 3 3 3. All right, I just tell you 2 are same and this is not same. So so we have 6 total, 6p6. Wait a minute, students. I have to give a planning 6p6 and 6p6 and 2 same and 2 and 3 same. Hold on. So 2 and so 6p6 and divided by, we have to answer here. Yes, student, this is, I think, clear. Now we have to discuss here what number to multiply here. Reason is what, if I show you the concept, here, these three are not. If I show the branch, so you can understand from here, whenever these three are confirmed, for example, not, and not square, not score, not score. So here, no problem, same branch. But after that, we have some possibilities. What is possibilities when we have? So for y, this is a I talk about y, not score, not score, not score. But then we have a three options for this one. Two options we have for score, and one option is for not score. And it means here we have onwards, we have a branches. It can be split like this. Okay, so that is why. But question comes, how to find this one? So what is the way how to get this one, students? How to get these answers? Okay, because they are some mix. So some values are we have a not score and some is score. So what is the method? Student, we have done many times. Whenever this is a no problem here, students, okay, because the same branch. But here we have a many branches. How to find these branches? So 3p3, 3p3, why? Because this 2 from here and 1 from here. Repeat my words, because 2 times 2 is a scoring and 1 not scoring, and that is what 3p3 for that. And 2 are repeating, same thing are occurring together. So 2p2. This becomes this answer, and if you simplify, this will give you 3. So you write this completely, or you write only 3, no problem at all. Same story here, students. What to write here? Again, if you look at carefully, same story here. So this is a power 3. Power 3 means x is a score, and score. And now we have this condition. Now for y, we have 2 not score and 1 score. So same story, 3p3 and divide by 2p2. Why 3p3? Because, student, there are 3 attempts, okay, and there are 2 repeating. Repeating means not score is repeating. So that is why. And we will not consider this one. Reason is why, because we have a same branch, score, and that is why we're not considering these. So we have to write this way. So we have two choices. If you write 3p3 over 2p2, or you write 3 directly, no problem at all. And when we do 3, whenever 2 are same and 1 different. So out of 3 attempts, 2 are same, 1 different, we multiply with 3. And if all different, 3 will multiply by 6. And in 3 multiply only when we have a 2 different and 1 same. I think clear idea. And now I'm going to type in calculator. And when we type this in calculator, let me check, students. So when we type this in calculator, so what answer is coming with me? Let me check. So very long working, but anyway, I'm just checking. The answer is coming. The answer is coming. So 1 minute, just a minute, students. Yeah. So answer is 0.0914. I hope so the point is clear. And this was a little tricky, only tricky part, how to know where how much you have to multiply. And I hope so you got a point, and question is completely over. Question number 5, student, we have a certain area, okay, in A, the probability that snows on any given day is 0.7. So probability of snow is 0.1, 0.7, and independent of all days. Find the probability that week 7 days is It's no at least 5 days. Out of 7 days, so when I say at least 7 days, student, at least 5 days, sorry, it means, students, it means 0, 1, 2, 3, 4, 5, 6, and 7. So he talked about at least 5 days. At least 5 days means 5, 6, and 7. So, and N is what? Sample of 7 days. And R is what? We have a 5, R is 6, and R is 7. Probability of favor, I talk about the snow chances is 0.7. And Q becomes 0.3. Now, student, I'm going to plug in the values, and topic is because binomial, you can see NCR, N is 5, sorry, N is 7, 7C5, 2 brackets, then 7C6, then 2 bracket, and lastly 7C7, 2 brackets. So first is a Q. Q will come in each first bracket. So 0.3, then 0.7, 0.3, then 0.7, 0.3, then 0.7. And what is the power of this one? 7 and 5 difference. 7 minus 5, then 5. 7 minus 6, so 6. And 7 minus 7, so 7. And if we type in calculator, students, so what answer is going to be 7C5, okay, and then 7C6, and lastly 7C7 and 0.7 power 7, and answer is 0.647. I hope so. The point is very clear. B part, a week in which it snows at least 5 days out of 7 is called a white week. Repeat, he's saying, so it means this is considered as a white week. All right. At least 5 days out of 7 is called white week. So probability in a 3 randomly chosen weeks, at least 1 is white week. So it means, students, it means sample this time is 3. At least 1 white week means what? At least 1. If I talk about 0, 1, 2, and 3, sample of 3 only. So at least 1 means 1, 2, and 3. I don't need 0. So what I'll do, student, it's sum of the all probabilities is 1. So I will do what? I will simply 1 minus x to power 0. And the question comes, what is P and what is R? So because we consider white week, so this is a P value. So 0.647 is a P value, and Q value is 1 minus this. So 0.3, 5, and 3. And what to write it, students? 1 minus 3C0, and here 3 minus 0, here 0, and Q comes here. So Q comes here, and I can say here, this is clear. Okay, 1 x minus 0, I think clear point. At least 3 is asking, at least 1. Okay, so here I'm writing 3.53, and here I'm writing 0.647. And now I am typing in calculator. So 1 minus 0.353 to power 3. And answer is giving us 0.956. I hope so, student. The point is very clear. And this part is also over. Next page, we have a C part. Here's a different area. The probability that week is a white week is 0.8. So it means now 0.8. And suitable approximation we have to use. Find the probability as 60 random chosen weeks. It means we have sample of 60 weeks. Fewer than 47 are white. Fewer is called less than 47. And if we draw a continuity correction, because whenever suitable approximation concept, we have to go for continuity correction. 1 value bigger and 1 value is smaller. And from here, go backwards. We have just do 0.5. So x value is less than 46.5. Okay, now I have to convert, okay, what is the way of conversion, students? So 46.5 minus mean by deviation. But we do have mean and deviation? No, we'll find it. What is the mean value? NP. N is 60 and 8 is 0. This one. So this cancels, 6 8s are 48. So mu value is 48. And what is the deviation, students? So deviation formula is NPQ and root of the whole thing. Inside, N is 60 into 0.8 into 0.2. Okay, so inside value, I'm getting 60 into 0.8 into 0.2. I'm getting 9.6 inside. So student, now I'm going to plug in these values. The rest part is easy. Mean is 48 and deviation is root 9.6. And when we get in calculator, this number is giving us is negative answer 0.4841. And student, was a rule, right hand side positive value, left hand side negative value. But there's a negative value is here and negative 0.4841. And this is called lesser. This portion is called lesser. But do you know negative values are not in table? If I draw same values, same table, if I make it, but convert into positive section. So this area and this area, these two diagram will give you same probability. Make sure same probability. And how to this white region is called phi of 0.481. But I'm looking for this portion. This is called 1 minus phi of 0. That. So it means I can write it now here. 1 minus phi of 0.4841. Okay, now students, we have to check it. What is the value? Go table for it. So 0.4. So 0.4, let me erase this all. Okay, select all and delete. Okay, so I'm looking for what number, students? 0.48, 0.4 here. 0.484. 8 is here and 4 is this. So last number, no need. So 0.6844, 6844 and 14 add. So 6858. So I'm getting 6.6, so 0.6858. So 0.314 and 2. But after rounding 3SF, we are getting 3014. I hope so. The concept of the question is very, very clear. Question number 6, students. 3 coins, 1 coin biased, and probability of obtaining head is 1 by 3. Okay. And second coin is biased, and the probability of head is 1 by 4. Third coin is biased, and probability of head obtaining is 1 by 5. So it means, students, all probabilities are different from each other. And he said that 3 coins Harry throws, okay, and the variable X is a number of heads he obtains. And draw the distribution table. So this kind of question, student, don't take risk and make it, some student try to make it directly. Don't take risk directly, okay? You have to make this kind of diagram, head and tail. The second coin, head and tail, and then talk third coin, head and tail. So, and this branch is head is 1 by 5. So third coin, 1 by 5. And tail is naturally 4/5. So these values I'm going to copy and paste. I can make easy for me to make it. And I'm pasting again here. And last number. And the middle one, what we have, student, 1 by 4 head. So 1 by 4, 1 by 4, 3 by 4, and 3 by 4. The top one is 1 by 3. Now, students, he's talking about is a number of heads obtained. So we have many options. Okay, so we have many options in case if 0 head means tail, tail, tail. So if I check it and multiply these values, what I get, students, 5 4s are 5 4s are 20 into 3, 60. So all denominator values are going to come 60. And 4 2s are 8, 8 3s are 24. Now talk about one head. One head, how to do it, students? One head, check it. One head, we have those branches when one head comes. So check, this one is one head. I put arrows, one head. In this branch, we have one head. And this branch, we have one head. So best idea, I will multiply the numerators and add them. So look, students, 1 3s are 3, 3 2s are 12. Repeat. So sorry, 1 3 3 are 6. So we've got a 6 from here. Second branch, 4 1s are 4, 4 2s are 8. Here, 4 3s are 12 and 12 1s are 12. And I'm getting 26. So 26 over 60. I'm not caring about denominators because that is common sense 60. Now I talk about two heads. And then I will talk about three heads. So student, this two heads, okay. Two heads, which branch? I erase this all single head branches. Now take two heads. So which branch we have two heads? This branch we have two heads. Okay, make an arrow. This branch we have two heads. And this branch we have two heads. Again, what I'm going to do, students, this I'm erasing, and now I'm writing the upper numbers. 4 1s are 4, 1s are 4. 4 we're getting. And what about this branch? So I'm getting 3 1s are 3, so 3. And last one, I'm getting 2. So I'm getting 2. So 7 plus 2, 9. So 9 over 60. So 9 over 60. Fourth one, we can do directly also. Okay, 3 heads is no problem. Top branch. So I got a 1 1 1. 1 over 60. And some of the all values will be 100% 1 if you check even. This is you add, you got a 50, 59 plus 1, 60. 60 by 60 is 1. So I hope so. This part is very clear. And now let's go for the next part. He's saying Harry has two other coins, each of the which is biased. So the probability of obtaining a head is is a P. Repeat again. It means the new two have a head obtaining both are is P. So both are having P. Okay. He throws all 5 coins at the same time, and random Y is a number of heads obtained that, okay. So head obtains. So head obtains, and we have given this condition. We follow this condition and find the P value. So students, 0, what does 0 means? Repeat again, what does Y represent? Y is a number of the heads he obtains. So 0 head. And 0 head means, students, if I talk about tail, 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 so it means very simple. If you check it here, tail, tail, and tail. So that is 3 tails. That means 0 head. We have already 24 over 60. 24 over 60. So this number we have already 24 over 60. Okay. I talk about 0, 0, 0, head, 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 and 2 more heads are there. Sorry, no head, no head, no head I talk about. So I am writing here 24. It was 24, I think, right? 24. Yes, 24. So I'm writing here not head, not head, not head, not head, and not head. So these three numbers we have already 24 over 60 and times 2. Other one is what? There's a P's actually, head. What's not head? 1 minus P. And 1 minus P, 2 times of putting square. So this is a probability of left side. Now, what about the right hand side, students? So he's saying that all 3 plus 2, 5 is having heads, okay? So it means now I talk about head, 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 and head. And that we have already behind. So 3 heads probability on the top branch is 1 by 60. So 1 by 60, which I'm writing now here, and 1 by 60. So I'm writing here 1 by 60. This is for 3, and 2 new are PP. So I'm writing here P square. Now, student, we have to solve it algebraically and get the answer. First of all, 60, 60 cancel out. This 6 will come down, and 6 4s are 24. And I have get this kind of equation. Now, student, what to do? After this, we have to expand it. Okay, I have two choices. I can expand or I can take directly root rather than applying it here. If I apply the root, okay, so what I will get, 2, 1 minus p equals to positive and negative p. So 2 times 2, 1 minus p is equals to positive p, and 2 times 1 minus p is equals to negative p. So I'm getting here 2 minus 2p equal to p, and 2 is equal to 3p, and p becomes 2 by 3. This is my answer number 1. Second one, 2 minus 2p is equal to negative p, and 2 is equals to, this goes there, p, and p is equal to 2, and that is not possible because probability crossing 2 is not possible. So not possible because probability always less than 1. You know it very well. So that is why our answer is a 2 by 3. I hope so. The concept of the question is clear. Question number 7, students, we have, okay, the 8 digits we have are arranged in a line. Okay, and how many different arrangement are there if there are 8 digits? Okay, so how many repeatings are 2 and 4? So 2's are 2 and 4's are 3, and others are how many? 5, 3, 8. So 3 are others, and total 6 plus 2, 8. So we can write 8p8 divided by, because 2 repeating only, same number repeating. So 2p2 into 3p2, 3p3. Or you can write 8 factorial by 2 factorial into 3 factorial. So don't forget it. And answer, if you type in calculator, answer is coming with us, is 3360. Next question. Next part, next part we have, find different arrangements are there, 8 digits in which there is a 2 at the beginning and 2 at the end, and 3 4s are not all together. Not all together. Okay, this means we can plan here when no conditions. Okay, no condition means so wait, 1, 2, 3, 4, 5, 6, 7. So starting with 2, ending 2, and we are not caring about the 8s. Sorry, we're not caring about the 4s. So student, what to do in this condition? Let me write it now here. If 2 appear on ends, then what is answer? So answer is 1, 2, 3, 4, 5, 6. So 6p6 and divide by 3p3. Why this so? Because there are very well 3 4s are there, because 2 are blocked. 2 students, they are blocked. So 2 cannot move. 2 cannot move, 2 gone. But 3 are repeating. So that's it. And this we check it when they are together. So 6p6 and divide by 3p3. And this answer is coming 120. But now we talk about same condition, and I talk about when all 4s are together. When all 3 4s are together, I count as a one block. 1, 2, first 1, 2, 3, 4, 5, 6, and now 1, 2, 3, 4. Now, what is the answer if 2 appears on both ends? Okay, if 2 appear on ends, okay, at the ends, okay, on the ends, and all 4s are together, and all 4s are together. So answer is naturally is a 4p4. You may ask reasons, so where are the 2 repeating, 2 are blocked, say not repeat, I will not count them, and 4 inside, I will not count them even. So 4p4 is 24. After this, if you subtract them, because we have to find out when they are not together. If 2's on corners, on the ends, and all 4s are not together. So so I'll subtract. So first number I got it 120, and now 24. So 120 minus 24, we are getting here 96. Clear. And let's talk about last part. Last part, student, what question we have? 3 digits are selected at random, and from digits we have this one given, or at same conditions, and there are same condition we have. I just go back, and this data is very important for us. Copy, and I'm using it now, next page. Okay, now student, let's try to do it. He's saying what is condition we have? Find the probability, then 3 digits are different. Okay. It means all are not same. It means naturally there are 2 twos and 3 fours are there, and other 3 numbers are total different from each other. So I'm saying here 2s, 4s, and other. So I think the idea is very clear. So let's make a plan. If I take a 1 2, 1 4, and 1 from the others, so you look at it all different. Okay. And second option, if I take a 1 2 and no 4 and 2 from others, I cannot take 2 from here because they are two repeating otherwise. Or if no 2, 1 4 and 2 from others, if both are not there, and 3 from here. So we have 4 options to in total, and let's see how we can do it. And first is our total because probability is asking for. Probability formula is what, students? Favor up, and total down. And so let's see how we can do it. First of all, because we have here condition number 1, we have here 2 twos. A very important part, I just tell you, if he asking not probability, repeat my word, this is one of the most important point which I'm discussing with you, and that is important. If the probability word is not there, right, students, I will take I will take this 3C1 only, that's it. 3C1 only, that's it. Okay, because these are repeating, I will not count. Okay, they are same, sorry. For example, 2 as 2s are there. So which 2 will come here? I will not aware with that. Okay, so I will not write 2C1. I will write only 3C1 for this. But now, because the topic of the probability we have, and we have a special criteria, then 2C1 from here and 3C1 from here. So I'm writing here 2C1 into 3C1, and times from here I need 1. So this is a rule, and there's a 3 into 2, 6. 6 3s are 18. So we get here 18. Okay, let's do option number next. Now I need 1 here, 1 from here. So 2C1 and 0 is not required, leave it. And from here I need 2. So 3C2. 3C2 is basically 3, and 3 2s are 6. So we are getting here 6. Next option. Now I'm out of the, how many 4s are there? 3 4s. Out of 3 4s, and I'm looking for 1. And from these 3, I'm looking for 2. So this is the 3, and 3 3s are 9. And last option, students, all 3 taken from here. So 3 3s, 3C3, we're getting 1. So answer is coming with us 10, and this is 24 and 34. So we are getting here total 34. And probability we are looking for, student, what is the probability formula? And there are the options, we have it. And total options, total letters are there are 8. And I have to select how many? 3. So 9C3. These are total options. Sorry, not 9. I think 8. Sorry, not 9. 8. 8C3. And answer is coming with us is 17/28. I hope so. Idea is clear. Once again, I repeat the most important part. If this probability word is not there, and this repetitive elements are there, and second more important part, you can say that 2s are same. Look at here, this 2 and this 2. How we know which 2 will come here? So if we have no probability word is there, I will not count. I will leave as that. I will just care about this one. I will not do these things. I think idea is very clear. But when we have the probability words there, then we have to consider which 2 is coming out of 2. 1 I will take, and 2C1. And which four will take it? So 4C1. Sorry, 3C1, because there are three fours are there. I think idea is clear, and that's it. I hope so you got idea. So whenever probability words come, we will try this way. And paper is completely over, and best of luck for upcoming exam. And pray for me. Assalamu alaikum wa rahmatullahi.